Well, thank you guys so much for joining us. My name is Bob Mitchell. I am the account manager for the Southeast United States for Purkeys, and have my mustached friend Kim Campbell. Tim Campbell. He's our key account manager in California, soon to be over in North Carolina. We thank you guys for joining us here today. As we mentioned before, if you have any questions, anything you want to talk about, put it in the question box there. But let's go ahead and get started to talk about what we're going to do to prepare for the summer. I live in Florida, so it's been summertime since February 15th here. So we have been preparing, but across the rest of the United States, maybe not so hot yet, but it's getting there. So we want to make sure that we're preparing our fleets, our batteries, our reefers, lift gates, whatever it may be, for the heat that's coming. So that's kind of what we're going to talk about today, just talking about peak performance to get us through the summer heat. So summer affects electrical systems and batteries in different ways. The heat does a lot of different things. High temps increase the rate at which the battery will deteriorate, resulting in a shorter battery life. I came from the battery background, and we would often say that heat kills a battery, cold exposes it. What you do in the summer is destroying your battery, and then that first frost comes along is when the battery breaks. So we want to help keep that failure rate down and your battery's up and running. So high temperatures increase the rate of sulfation. Sulfation is one of those things that is killing your battery or will kill your battery. And some applications that we're going to talk about get a little bit stressed more in the summer than they do in the wintertime. So we talked about sulfation, and this is something that can be avoided. As you can see, when a battery sulfates from the graph here, you get a sludge buildup, and that's where you start to get when that buildup starts affecting the plates there, starts affecting the positive and negative plates, and that's where you get a short circuit and your battery will collapse. One of the top ways to keep your battery from sulfating, obviously, is to keep it fully charged. Keeping a battery at 13.2 versus 12.7 is going to drop that rate of sulfation. And sulfation is just a natural reaction that forms on both electrodes as the battery is discharged, as I just read off of there. So a properly managed battery, if you look at the sulfation graphs there, you can see not properly and properly managed. You won't be able to see that in the battery, obviously, but trust us, you want to keep the battery completely topped off to avoid this from happening. And as I mentioned before, why do electrical problems show up on the first cold day? Your battery, there's a reason your batteries are ranked for cold cranking amps. They're tested at that. When it's 80 degrees outside, your battery's humming along at 100%. Your alternator, your starters, they're able to put out their maximum output. But as those temperatures drop, you'd think, it drops down to 85% when you get into really cold temperatures. Obviously, at zero, it drops to 65% efficiency rate in a battery. That's causing your starter, your alternator to have to work that much harder to get going. The battery isn't able to even put enough juice to a lot of starters, and the alternators obviously have to work harder to get that going. So a good PM process during the summer months will reduce these for the winter months coming. So you're planning for the summer, planning for the winter by doing work in the summer. All right, so what equipment we're going to get to our first poll question. We're going to ask you a couple of poll questions throughout this, and we want you to have a little audience participation. We want you guys to jump in and help out. But what equipment can benefit from a good summer PM? We don't just want to do them in the wintertime. We want to do them in the summertime. So you got 4 options there: trucks, reefers, and heaters, lift gates, or all of the above. So go ahead and click on what answer you like. What equipment can benefit from a good summer PM? We'll give you a few seconds to participate. Tim, do you know the answer?
I think I might know. I'm just not sure if this is a good question, Bob.
Very good. Glad you're paying attention, buddy. All right, that looks like most of us have answered. Thank you for your participation there. Let's see what we came up with. Holy cow, we got some brainiacs on this call. Look at that, 100%, all the above. Of course, everything can benefit from a good summer PM. Thank you for that. So The biggest issue with all equipment, no matter what season it is keeping the battery charged. You want to have that battery topped off at a 13.2 to kick that starter on, to make the alternator work less, whatever it may be. You got to have your batteries at a full state of charge. So, if the battery's not at a full state of charge with trucks, you have idle restrictions, you have higher cab loads. They're going to need their batteries working more. There's so much more electronics on a truck now, as you know, with the GPS and different systems that are going on there. So, it's very important, obviously, to keep that topped off as much as possible. Lift gates as well. We're dealing with longer cycle times. A lot of times, trucks are running shorter routes in the cities and have higher cycle time and not enough charging time in between. And there again, warmer temperatures are causing the battery to operate at 100%, but it's putting a little bit more of a tax on the battery as well. Reefers, because of where the battery is located, there's going to be issues there. They've got increased parasitic loads because of all the electronic equipment on reefers. So this is definitely draining those batteries down more so. And then sometimes there's heaters. We have a few applications where somebody actually needs heat. Thinking of like some paint companies where they can't allow the paint to coagulate. They got to keep it at a certain temperature. It's not necessarily keeping it warm, but it's keeping it at room temperature. So if there's increased parasitic loads with that, and there's less runtime on those as well. So all these systems need a good PM and need more care during the summertime. And we're going to talk about a 3-step process. Mr. Tim's going to take us through that. So Tim, take it away.
Excellent. Thanks, Bob. Great work. I think that was a perfect explanation on some of the basic battery info there. And now let's jump into it. How are you going to ensure that you're ready for summer? And we can boil it down to 3 steps here. Maybe some of them have a 1A, 1B, 1C, but let's jump in. Number 1, of course, as Bob was saying, batteries are certainly going to be the heart of any electrical system. You're always going to want to make sure that your batteries are in good working condition. And with that, it takes some, it takes charging, and you got to look at what's discharging those batteries too. Testing the batteries, of course, you really want to have a open circuit voltage of at least 12.4 volts. I'd be considering that towards the low end there, but anything under that, you're really going to be damaging those batteries. As Bob said, those problems are going to really start surfacing their heads out in the winter time when that extra capacity is needed. And testing the batteries, with anything, you do want to isolate the batteries. Just about anything in the Class 8 industry, you're going to have jumped batteries to put them all together. That way you get the benefit of both batteries. But if you're trying to test batteries and they are connected together, you're not going to get a true reading off of each individual battery. It could be masking issues. And this is something that sounds simple enough, but you'd be surprised the number of people that do have just all sorts of green fuzz growing on those terminals. You certainly want to make sure that this is a clean area, and that goes for anything electrical. We'll get into that a little bit more down the line, but anything that's not a clean, solid, tight connection, it's going to cause issues in an electrical system, especially when you're testing batteries. You want to make sure that you're getting an accurate test. And this is one that gets missed quite a bit. When you're doing any testing on a battery, specifically load testing, we've seen a number of people that'll clamp on their testers straight onto the threaded studs on these batteries. That is very much not a good contact area, especially for doing any load testing. Grab a set of lead post adapters, install those, make sure that they're properly tightened, and that's where you would want to clamp onto. And of course, just as we were leading up to here, finding a good battery tester, that's something that can put a physical load on the battery, is always going to be great. Something that can test the cold cranking amps against what it's rated for. And just give you a little bit of a heads up, especially as Bob was saying earlier, chances are a lot of these issues aren't going to show themselves in the summertime where the loads are a little bit less and the batteries are going to be a little easier going. But this is all preventative stuff that can keep these batteries healthy throughout the summer leading into the winter.
Tim, I will ask you this, just because we're talking about testers. Is there obviously just using a test light is probably not going to get it done. Would you agree?
Well, I would have to say if you have eyes good enough that you can see how bright that light is, and I don't know how you test a load on there, Bob, but
Sure.
yeah, very, very true.
Having a good multimeter is going to be able to save you a lot of headaches as far as that goes. And anytime you call us with some of our Purkey concerns, one of the first things they're going to ask you is, what's the readout on the multimeter? What's it showing, and that sort of thing. So it's make sure you have a good tester for that. I think you'd agree with that, right, Tim?
Yeah, and it's probably been said in some of the previous Purkeys webinars, but really, if anyone in the facility still has a test light, I'd say throw it away now. It's 2025. Sure. You can get multimeters. Yeah, even a cheap multimeter is better than a test light itself. But obviously, the higher the meter, the more functions you get. If you don't need all those functions, you're fine. But please have some kind of a digital readout on these things.
And not to hijack that conversation, but we do a multimeter test webinar that's free to you guys too. So those of you that are on the webinar now and you're a little nervous about multimeter stuff, we do a training on that as well. So a shameless plug for Purkey's multimeter webinar.
It's probably our top attended webinar. I'll say it's very, very useful. That's a great point. So off of batteries, let's jump into the cranking system. I think I have a starter right here above me, so perfect segue there. Here's something to keep in mind, and that's going to be the, I guess you'd say, the allowed rate of voltage drop that you would want to see in a charging cable. Obviously, the lower voltage drop that you have, the better, but we'll have people that think that they have starting issues or battery issues, and it ends up being a cable, and it could be the power cable, your ground cable, or the connections in between at the ends, the ring terminals, the crimps. So you do want to test these cables. They are the lifeline between those batteries and that starter. Even if you have a vehicle that's cranking slowly, you tested the batteries. Hey, these batteries are testing out fine, but you're still having a slow crank. Don't jump into being a parts swapper. Check these cables. And this is a test that needs to be performed under load. I mean, you could have perfect voltage with no voltage drop between a battery and a starter, running it through a paper clip. But once you try to flow amperage through that, that's when you're going to see that voltage drop. So at 500 amps is the standard, and you want less than half of a volt of voltage drop during cranking. And of course, you're not going to have much for healthy batteries if you don't keep them charged. So very important to touch on your alternators as well. And again, this is something where you would be doing a test where there is amperage flowing. This is a little bit different than the starting amperage. Starting, it's going to have that 500 amp hard set rule, half a volt at 500 amps. With the charging systems, it is a half a volt as well, but it's going to be at the amperage of your alternator's rated output. So whether that's a 165 amp alternator, you would expect no more than half a volt of voltage drop when it's at 165 amps. And of course, there's just a little bit different on the diagram there, but really anything between that starter, alternator, and batteries, all of these connections are the lifeblood. It's how all of that current is being carried. If there's issues, whether it's the connections, the cables, sometimes it could be a hidden issue. If there's, sometimes there's the fusible links where it's a wire that's made to fuse itself if there's an issue instead of having a physical fuse. And it's things that you need to look into and make sure that you're not having any issues inside the cables or at those connections. And looking at them physically, a lot of things can be hidden by the jacketing. Really, the best way is to check for voltage drop under load. And from here, you guys have been nailing these poll questions, so let's see if we can crank it up a little bit. There's a pun in there somewhere.
Or a little pun, nice.
The question here, let's go ahead and see if we can get some answers coming. This is, what is the spec for the TMC recommended practice, that's RP 129, for cranking cables? I gave you guys the answer just a little bit ago, and remember there was a little bit of a difference between the cranking standard and the charging system standard for voltage drop that you're going to see. So a couple options on there. Some of them have amperage built in. One of them, A, does not mention amperage, and a couple different values as well. Bob, you think you got this question?
I'm sorry, I wasn't paying attention. What?
Oh, you think you know this answer?
I think I got
Yeah. All right. Well, all right. It looks like people are maybe a little less confident in this answer. They knew yours right away.
it. They jumped on mine, didn't they? Oh, easy sauce there.
Yeah. No, we're getting some good answers in here. And again, really any of these, you really need to be checking for that voltage drop in these cables. As I was saying, it can hide so many potential issues underneath the jacketing or heat shrink. Sometimes some people use heat shrink that doesn't have that adhesive, the glue inside to keep out any elements from getting in there. You can start growing corrosion. And as many of you know, corrosion loves to wick up copper wires. If there's corrosion at the end, chances are that corrosion is starting to grow down through that wire, and you're not getting that full set of strands, the copper strands that you're paying for. And at this point, I think we've tapered off on the answers. Let's see how everyone did. Look at that. Majority's nailed it. That was the answer for the cranking cables, that TMC RP129. It is half a volt of voltage drop at 500 amps. But more than anything, the importance of this question is just to drill it into you that, hey, I think that there was a standard out there. I don't expect anyone to know this off the top of their head. But if you can look it up online real quick, what is that standard? And just know that it does need to be tested under load and test that voltage drop.
So the idea, Tim, being there is that you test it under load and you see, oh man, this thing's, I'm getting a voltage drop of 0.25. That's not good. Well, no, that's fine.
Yeah,
right?
Yeah, more than acceptable. And,
Yep.
I mean, if you're getting, it depends on the amperage as well. If you're only pulling
at 500 amps, yes, sir.
Yeah, it could be wild, but yeah. Well, thanks for the answers on that. Let's roll in here. And of course, just to wrap up that section, it's as easy as 1, 2, 3. Maybe there were some other little bits in there, but batteries, starters, alternators, and certainly the cables that connect them all. And jumping into the next section, I'll kind of start this one off and turn it over to Bob. But what are you doing to ensure this trouble-free summer? And again, we're going to talk a little bit on the alternators, starters, and batteries, just as before. Really just reviewing the specs that you're running in your fleet and making sure that your replacement parts are meeting or exceeding those specs is going to be very important. Of course, with batteries, you have a couple things to consider. It's the battery chemistry itself, how it's put together. You could have the flooded cell or the AGM style, and getting the correct cranking amp, specifically when you're talking on starting batteries, reserve capacities, when you're talking anything that's going to be extended loads, whether that's lift gates or any hotel loads, maybe it's inverters or something with a sleeper cab. And another thing is warranty. A lot of companies do talk about warranty, particularly with batteries. Keep an eye out. A lot of you have already known the prorating period on these. It's not a lifetime warranty where they're giving you a new battery. It's very much going to be prorated on those years.
So Tim, because you're discussing batteries, so having a 1000 CCA battery is the best, right? That's what you should have. The more cranking amps, the better, right?
It's something we get asked a lot, and thanks for bringing that up, Bob. And, generally you would think that a higher cranking amp would be a better battery, but it depends on the application. So there's really no perfect answer on that, especially with mixed use batteries where it's going to be used for cranking and we'll say deep discharging. Of course, we have the deep cycle batteries that probably a little bit better for anything like lift gates where you expect the battery to fall down, could be resting at that lower voltage for a little longer before it comes back up. Starting batteries, anything with the higher CCAs, you're probably going to be looking at starting batteries, and those batteries are very much meant to have a quick jolt, crank that starter, alternator comes in and tops them right back off within a few minutes. They're really not meant to be deeply discharged. So it's tough to say, but that's a great point to bring up, and it's something that you probably have to research a little bit depending on what those batteries are used for. And if you have any questions, definitely reach out to us at Purkeys. We love talking this stuff. Bob was a battery man in his past life anyway.
Well, and a lot of times if the application's for 750, some guys think, well, I got a 950 in there. That's going to be even better. You should go with the specifications. And a lot of times a 950 or 1,000 is the heat's going to affect it more because it's got more lead into it, less fluid into it. It's going to get hotter. And again, we're talking about dealing with the heat. Having a battery that's kind of overkill is not necessarily going to help your system in the long run.
Yeah, great points. And from that on to starters. Of course, gear reduction compared to these old starters without having any gear reduction. Gear reduction is something that's going to take down the necessary amperage significantly versus a old direct drive starter. Just about anything nowadays should be gear reduction, but if you think that you found a killer deal on a starter that technically bolts up to your engine, maybe look into the specs and make sure that you're getting what's needed. And again, like we talked about earlier, make sure that it's matching that OEM spec. And of course, the kilowatt rating, the actual force that you can get out of that starting motor. Mm-hmm. Again, making sure that you're matching that OEM spec. Idle mitigation systems are another thing. If it has something where it has an auto shut-off feature where that starter is really going to be working overtime, that's something that needs to be taken into account. Those starters are manufactured specifically to handle that extra wear and tear. And just like on batteries, we mentioned warranty as well. It's something to keep in mind with anything that you're getting. And always look at the warranty with a grain of salt too. Not only the warranty period and the terms, but the company that's behind it. Is it something where they're going to be really tearing you down, trying to get a warranty processed? And you have to keep in mind with anything that's battery starters or alternators, there's a lot of variability of what could actually be the problem. Again, we talked cables at length earlier. We have heard a lot of stories of starters getting sent in for warranty. They get the new starter, they end up having the same issue. It ended up being an issue with their cables. So a lot of these, they are very much going to test the systems before they issue warranty credit typically. And finally, wanted to talk about alternators themselves. I mean, you have batteries and you have things that are taking the juice out of them. How do you get that juice back in them? They have to be recharged. You're not going to swap out batteries like you do AA's in your RC car. Alternators, of course, things to take into consideration would be brush or brushless if you're feeling fancier, if that's OEM spec. Certainly much higher life expectancy out of a brushless design, but you're going to see a much higher cost on that as well. Getting something that has the correct amperage output, and of course, keep in mind if it's a sleeper cab that's going to have all of those auxiliary loads, you're going to want something with a little bit of a higher output. If that sleeper cab, everything was spec factory as far as the accessories, you should already have a appropriately sized alternator for that. Having remote sense options and really the optimum charging profile for whatever system you're running in there battery wise. And we'll again touch on warranty with the same caveats as what we mentioned before on the starters and the batteries themselves. Just keep an eye out for company reputation on that. How easy is it to have a warranty processed? And I guess even on top of that, I would say the customer support of that company. If they're someone that can walk you through over the phone and mention the TMC RP129 of, hey, check the voltage drop first, not because we want to deny a warranty, but because we want to save you time of swapping out a starter, swapping out an alternator when it could be a cable issue. And also, we were talking about what you might need the alternator for, the sleeper cabs, anything that has a inverter that if you could be running a full microwave in the back or any auxiliary power takers off of that alternator, you're going to want something with a bit of a higher amperage. And this is also an area where you want to make sure that these connections are clean and tight as well. And one thing to keep in mind on inverters is just like Bob was saying on batteries, bigger isn't always better. A lot of times when you see a higher wattage power inverter, You might think, yeah, that's great. I really love having this extra wattage, but extra wattage really isn't a fantastic thing, specifically when you're talking power inverters. All inverters, no matter where it's coming from, they are going to have a little bit of a parasitic draw. A lot of inverters do have sleep modes and power save modes, but there's always going to be a parasitic draw, and definitely a power loss factor too between the power inversion from DC to AC. If you're running a 2,000 watt inverter and you're only needing it for a 500 watt device, you're going to have a lot of wasted energy in that inversion process. So make sure that it's properly sized, and bigger is not always better. Another thing to really keep an eye out for is, hey, you think you found a great deal on a power inverter? It might not be. It could be a modified sine wave versus a pure sine wave. Without getting super deep in the weeds, a modified sine wave is, of course, AC is alternating current, swings from high to low, back and forth. Modified is going to be more of a square waveform than a pure sine wave, which is what you're going to get out of your wall outlets at your home. And that's going to be something that matches that, power distributions company, that sine wave much, much closer. Where you really run into issues with this is anything that could be like compressor based, anything refrigerators. You really want to go for the pure sine wave just for peace of mind.
Well, CPAP machines especially.
Oh, that's a perfect point, especially in those sleeper cabs. And of course, at the bottom, just about all inverters have some form of a low voltage shutdown or a low voltage disconnect, where maybe it just turns itself off, comes back on when it sees the voltage come back up. Maybe it sounds an alarm, but double check what that voltage is set at for that set point. Obviously, you don't want it to shut off prematurely, especially like Bob's saying with anything like a CPAP machine or anything medical. But at the same point, you don't want it so low that they're not going to be able to start that truck back up in the morning without some kind of a actual battery disconnect from the starting batteries and auxiliary batteries. And from there, let me turn it back over to Bob real quick to wrap things up on some alternate powering options.
Well, thank you, Tim. And we've seen, as the slide says, short power charging has gotten to be a lot bigger. We're seeing it in Tim drives a Tesla. He charges his Tesla when he goes somewhere. So, trucks are able to pull up and do shore power battery charging. Obviously, that's going to be very efficient. You're going to be able to keep that battery topped off. There again, the same thing that we've been talking about, getting the batteries at the maximum levels so that all the systems run well together. So optimum efficiency there. Driver training, you want to make sure drivers know where to plug in, and you're talking about 240 or 480 volts when you're talking about shore power. So you definitely want to make sure no mistakes are made there. When you make a mistake with a 12 volt battery, you don't really get too big of a consequence. You make a mistake with 240 or 480 is a bigger consequence. So liability that goes with that, making sure that make sure you have good driver training on what they should do when dealing with that. So one of the favorite things I like to talk about is solar. We've had some really good success and with solar panels and solar technology. 10 years ago, solar, I don't know, was that viable? I don't think we could get a lot of juice for the squeeze, if you will. But now the technology's kind of caught up, so we're able to use solar in a more effective way. What we have here is a temporary solar use panel. So it's just like it shows in the picture. You put it in the dash, you plug it into your cigarette lighter or power outlet, and it's going to pull some power from the solar panel and put it into your batteries. So while you're eating lunch and throw that in the dash, more importantly, let's say you're down, your truck's down and you're waiting on a part for a couple of weeks. Well, you have parasitic loads on your truck, your GPS, other things are drawing from those batteries. Having a temporary use solar panel like this, throwing it in the dash and getting some amperage back into the batteries is highly effective. And we've seen a lot of fleets swear by this recently. And aside from temporary use panels, we also have the permanent installed panels. This is actually a tractor that I helped install this panel on, top of the truck there. It's getting a lot of light as it's going down the roads, putting That's a 110 watt panel that's putting juice into the batteries. It's a sleeper cab. So the idle mitigation is getting more time because the battery is staying topped off. Well, he's parked during a run. He has to, what would be a 4-hour park. Now that he's got solar, maybe 4.5, 5 hours. And that, of course, is affecting the idle mitigation as well, allowing the diesel not to run, saving gas, all those things. So putting energy back in the batteries at opportune times, that's the key behind solar. And, we're getting some really good life from that, some really good savings from that from fleets. And if you want to know more about that, then by all means, please let us know. Same thing for reefer heaters or lift gates, putting those on top of the reefer trucks or on the liftgate trucks. You see here, these are actually 3 that are tailed together. So at each 110 watts, you got 330 that are going into the reefer batteries. So it's almost like, why not take advantage of it, especially here in Florida, especially here in the Southeast, but you're still getting we're still seeing a lot of good success in the Midwest and even in northern states because the sun's still out. There's still energy being drawn there. And it's free energy. Once you install the panel, you're getting free energy there. So I'm a big proponent of it. I know Tim's a big proponent of it as well. So we do have another question for you. Third and final question. We're going to see how you guys do here. But which one is not one of the benefits a fleet could use from using solar? So which one of these you're not going to see a benefit from? Reduced idle time, improved fuel economy, improved electrical system component life, or improved tire life? Which one of those doesn't fit? If we're using solar, which one of those doesn't give us a benefit? I'll give you guys a couple of seconds to answer that. Oh, we're getting there. All right, let's see what we have for an answer. All right, improved tire life is the answer. That is correct. You're not going to help your tires at all from having solar panels. One of the things I didn't mention as I was reading through these questions, improved electrical system component life. Yeah, somebody did answer that, but you might kind of go, well, yeah, what's it doing for electrical components? Well, like Tim talked about with the alternators and the starters, a battery that is only putting out 12.5 or 12.6, that starter is really going to have to work hard to get the vehicle started. The alternator is going to have to work hard to get the battery recharged. If you've got solar on that battery, now that 12.6 moves up to 12.8, 12.9. Alternator doesn't have to work as hard. Starter doesn't have to work as hard. So you are improving your electrical system all the way through when you have that battery topped off at 13.2 as high as it'll go, and improve fuel economy. Like I said, a vehicle that's sitting, the idle mitigation system, the diesel is going to run less because the battery's not going to have to start after X amount of time. It's going to get more time because it's got more charge into the battery. Did I explain that correctly, Tim?
Yeah, well, I was even going to add to that on top of that. It is the alternator is a belt-driven system, and the higher load, the more resistance you're going to have on that. So, with the waste energy in a diesel engine, it's got gobs of torque already, but it is something that it's still taking a physical load off of that belt drive system on the engine. So it's something that you would expect to see, certainly not a decrease in fuel economy, if anything, a positive increase. And just like you were saying on the component life itself, towards the beginning, you were talking batteries and state of charge, and certainly keeping a battery stored at a low state of charge at a low resting voltage is not going to be good for that battery health long term. The batteries love to be at a fully charged state. And if they're stored anything below that, it's going to eat into that battery life, just like you were saying, Bob.
And this is going to be way off topic, and I apologize, but I had a guy ask me about solar this week about how don't you have to keep the solar clean? Don't you need to get it? We're talking about doing a summer PM here. Well, if you do have solar panels, it does take a little bit to get up there and to clean them. what's a good, and because you've had solar, Tim, what's a good way to clean those solar panels?
Yeah, and I'll even lead into that a little bit with what I've seen in the testing of solar panels from just standard dirt and dust pollen on them. You'd be very surprised the small amount of difference in output from those panels, from a just filthy, covered in pollen panel versus a perfectly clean panel. Really, the output difference is minimal. I'm talking
Minimal.
less than 10%, which isn't nothing, but I think it's something that you should weigh the options and see if it's really worth getting up on the roof to clean the panels for that
Sure.
extra, 10 or 20 watts. And if anything, it's probably not a bad idea after first installing solar at high noon to go out, record the amperage that you're getting from those panels,
Sure.
and use that as a little bit of a benchmark. Maybe just test that every few months, see if you're still getting close to that amperage. Solar does degrade very slightly over time, but the lifespan is extreme. But yeah, as far as cleaning panels, really you don't want to use anything abrasive, a very like a stiff brush or anything. Definitely you want to use something soft. And same thing goes for chemicals. You want to stick away from a lot of the harsher chemicals. And frankly, just a little bit of Dawn dish soap and just some warm soapy water and a soft brush would be just fine. But really double check and see if they need to be cleaned by looking at that output. That's a perfect perfect thing to bring in, Bob.
Yeah, stick an amp meter on it, and hey, this thing's putting out what it should. No need to fuss with it, whether it's dirty or not up there. Huh?
Yeah, unless you're going for a photo shoot with a drone, I think you're fine.
Unless you really want to get on top. On top of the trailer. I get it. Okay, so that's covering a lot of what we talked about here. These, kind of getting you guys ready for the summer. Hope this was helpful to you guys. We're going to open this up for any questions you might have. Of course, we've got a Q&A box down there. I didn't see anything come up as we were going, but maybe this is a good time where you want to ask a question of Tim or I. We're going to give you a minute or two if you want to throw something at us. Do you have any questions, Tim?
I don't think so. No, this is love doing these webinars, and yeah, hopefully you guys are able to get a little bit here. I know a lot of this stuff is it's things that have been talked about quite a bit over the past, but it's a fantastic refresher, especially just looking at when you look at the big picture. A lot of people think, yeah, I really need to focus on getting the fleet ready for winter, making sure that I don't have any breakdowns, any issues there. But really, a lot of that stems from the maintenance that you do in the summer. So I think that this is a great webinar to have, and I'm glad that we were able to have you guys on here. And yeah, we'll see if any questions roll in.
Yep. I don't see anything, but whoop.
All right.
Okay, I don't see any questions here other than some silly ones from friends of ours. But anyway, thank you guys again. I'll reiterate what Tim said. We appreciate having you on here. We do these webinars as a partnership with you to try and help you out with your fleet as much as possible. Purkeys always wants to be a partner with our fleets and want to help you in the best way we can. We're always here and available for questions or if you need anything, any sort of training. We do webinars each month. If you want to see it's going to be a survey at the end of this. And if you want to see a different webinar or you want to, hey, would you guys cover this? Would you guys cover that? Give us some suggestions that way. Stick around for the next, as Tim and I log off, stick around for another couple of seconds, fill out our survey, let us know what we need to do, what we need to do better, or what we need to do less of or more of. And we're happy to be here. Thank you guys so much.
Thanks, guys.